So let's just move on further and talk about the solution of a quadratic equation through the second method, which is called as by completing the square. So what is the meaning of finding the solution by completing the square? So first of all, let us suppose I am talking about a question that we have to convert x square plus 4 of x into the formation of x plus 2 whole square minus of 4. As you can see over here, we have the term as x square plus 4x over here, and we have converted this particular formation, that is x square plus 4x, into a perfect square, or we can say we have completed the square as x plus 2 whole square minus of 4. So in the same manner, like we have this question over here, in the same manner we can convert any particular formation of this type. For an instance, we are talking about x square plus 4x into this formation, means into completing the square, or we can complete the square of any particular kind of this formation. So let us suppose if we are talking about that how we have converted x square plus 4x into this particular form. So let's just take x square plus 4x first. So let us suppose if I am talking about x square plus 4x and I am taking them as nothing but in the formation of a rectangle. So let us suppose if I am taking x square as nothing but a square, having the sides as x and x. Obviously, if we are talking about a square, then the sides of the square are equal to each other. So let us suppose if I am taking x square as nothing but a square, and if I am taking 4x as nothing but an area of a rectangle, an area of a rectangle. So let us suppose if I'm starting with x square plus 4x by taking this as nothing but the area of a square and this as nothing but an area of a rectangle, then we will convert this formation into this. So let's just see how. So let us suppose if we are starting by taking the square area as x, and x will be the side, so the area will be nothing but x square. So we have the term x square plus 4x. So let us suppose if I'm taking a rectangle over here, and the sides of the rectangle, or we can say the length and breadth of a rectangle is nothing but 4 and x. So the area of the rectangle would be nothing but 4 into x. So hence x square plus of 4 of x, we have the term. So let us suppose if I'm combining both of these together, means a square and a rectangle. So if I'm combining both of these together, the formation is nothing but x square plus 4x. But we have to convert it into a perfect square, or into a square, not a perfect one, into a square one. So let us suppose if I am actually cutting this rectangle, that is which do have a length and breadth as 4 and x. So let us suppose I am converting this particular figure into this formation. Let us suppose I am taking it as 2 and 2, means I have actually taken 4 length and breadth as nothing but of this form. So this is 2 and 2, means now we have the breadth as nothing but 2 and 2, and the length remain the same as nothing but x. So it means that we have the same value again, x square plus 4x, because nothing has altered over here except we have taken it into a half. Now let us suppose I am moving this particular half toward this side. Let us suppose I am moving this particular half towards this side. So let us suppose if I am taking it in this particular form, again nothing will alter, the values remain same, means we have x square plus 4x. So instead of writing x square plus 4x, I am writing it into the formation of x plus 2 of x plus of 2 of x. We can write it in this particular form because we do know that this is nothing but x side and this is nothing but 2. So the whole length would be x plus 2. So the whole length would be x plus 2. Hence, if we'll find out the area of it, so this would be x plus 2 into of x, because again this is nothing but a rectangle, this whole is nothing but a rectangle. So if we are talking about its length, so this would be x plus 2, because this length is nothing but 2. So this is x plus 2 and this is nothing but x. So the area would be length into breadth, means x plus 2 into x plus of, we are talking about the area of this particular rectangle. So as we can see, the length is x, the breadth is 2, so the area for this one is nothing but 2 of x. Now let us suppose I am completing a perfect square, or I am making a square over here. So let us suppose I am adding a square, a minus square over here, which do have the sides as nothing but 2. So let us suppose if I am completing the whole figure by adding this square over here. So if I am adding a square over here, then I'll have to subtract a square over here in order to balance everything. So it means that, as we know, the total length over here is actually x plus 2. So this is x plus 2. So means we have x plus 2 length and x plus 2 breadth. It means it is now a perfect square. It means we can write it into the formation of x plus 2, x plus 2x plus 2 square minus of 2 square. So hence at the end we can write it as x plus 2, x plus 2, because the sides would be x plus 2, x plus 2, and we have minus 2, means we have a square having the side as nothing but 2. So at the end we can write it into the formation of the area as x plus 2 whole square minus of 2 square. So at the end what we have concluded, that we actually have started with x square plus of 4x, and we have converted it into the formation of x plus 2 whole square minus of 2 square, means we have formed a square over here which is nothing but of the form x plus 2 square minus of square. Now we will use the same concept over here whenever we will form or we will convert any particular formation into completing the square. So let us suppose if we are talking about the algorithm which is involved over here, that how we will convert any particular formation into a square. So let's just see what are the steps that are involved over here. So first of all, suppose we have ax square plus bx plus c is equal to 0 is the given quadratic equation, and we just wanted to find the factors of it, or we just want to find the solution of it by completing the square. So write the equation in the form such that c on the right side. So if any quadratic equation would not be able to give the answer through the factorization formation, then we will go for completing the square. So always remember, whenever we can't able to find the factors using the factorization method, then we'll go for completing the square. And in completing the square, the very first step would be like we have to take c constant towards the other side, means towards the right side. So the next step would be like if a is not 1, means the coefficient of x square is not 1, then we have to make it 1 by dividing that number a everywhere. So if a not 1, then divide the whole equation by the coefficient of x square, that is nothing but a. So let's just talk about the next step. So the next step would be like, now add the square of half of the coefficient of x. So the coefficient of x would be of the form b by a, because if we are dividing this equation everywhere by a, so this would be of the form x square plus b by a, which is equal to minus c by a. So the coefficient of x is nothing but b by a. So the next step says that if we wanted to complete this square, we have to add the square of the half, means take the coefficient or take the coefficient of the x, take the half of it and take a square of it, then add it on the both side of the equation. So now add the square of half of the coefficient of x, that is b by 2a whole square on both the sides. Now further, the next step would be factorize the left side of the equation as the square of the binomial term. So we have to factorize, because on the left hand side we can form a square of a binomial term. And let's just talk about the next step. So the next step would be like take the square root of both the sides. So we can take the square root of both the sides and solve for the value of x, and then we can find the roots. Now let's just talk about the sums that are based on completing the square, which is related with that particular algorithm. So I am applying the algorithm step by step on the question. So let's just talk about the question number 1. So it says find the roots of this particular quadratic equation. So according to the algorithm, first of all, we will write this particular equation into the formation of. So let's just start the step number 1. So according to the step number 1, we will write the equation as 5x square minus of 6x is equal to 2. We have to take c towards the other side. So let's just talk about the step number 2. So the step number 2 was like we have to make the coefficient of x square as nothing but 1. So as you can see, we have the coefficient of x square over here is nothing but 5. We have to make it 1. So let's just divide the whole equation by 5. So the next step would be like divide the whole equation, or we can say divide equation number 1 by 5. If we'll divide the whole equation by 5, so it would be like 5x square by 5 minus of 6x by 5, which is equal to 2 by 5. And furthermore, we can write it as x square, because 5 and 5 get cancelled with each other, 6 by 5 of x, which is equal to 2 by 5. Let us suppose I am calling this equation as nothing but equation number 2. Now let's just talk about the step number 3. The step number 3 was like we have to take the half or the square of the half of the coefficient of x. Means as we can see over here, the coefficient of x is nothing but 6 by 5. So take the half of 6 by 5. So the half of 6 by 5, let us suppose I'm taking a half of 6 by 5. So the half of 6 by 5 is nothing but 3 by 5. It means we have to take the square of 3 by 5 and we have to add it on both sides of the equation. So the next step would be like we have x square minus of 6 by 5 of x plus of 6 by 5's half is nothing but 3 by 5, and we have to take the square of 3 by 5 and we have to add the 3 by 5 whole square on both the sides. So this would be 2 by 5 plus of 3 by 5 whole square. So this is nothing but the step number 3 which is involved. So x square minus 6 by 5x plus 3 by 5 whole square is nothing but is equal to this. Now just look for this particular formation. As you can see over here, we can write it into the formation of x square minus 2 into 3 by 5 of x plus of 3 by 5 whole square, which is equal to 2 by 5 plus of 9 by 25. I can write it into this particular formation, and if I'll see this formation, then we can see this is of the form a square. This is of the form a square minus 2ab plus b square. As you can see, we can apply an algebraic identity over here, which is a square minus 2ab plus b square, where a is nothing but x and b is nothing but 3 by 5, which is actually is equal to a minus b whole square. So using this particular concept, we can write this equation as x minus 3 by 5 whole square. So we have converted this particular formation, means the expression that we have on the left hand side, into a perfect square as x minus 3 by 5 whole square, which is actually is equal to 2 by 5. Let's just take the LCM over here. We have 25. So 5 will get multiplied with 2 over here. So 5 into 2 is nothing but 10 plus of 9. So this is 10 plus of 9. Further, we have x minus 3 by 5 whole square, which is equal to 19 by 25. Now we have to take the square root on both sides of the equation in order to get the value of x. So let's just move on further to the step number 4. Step number 4 was like take the square root on both the sides, take the square root on both the sides. So if we'll take the square root on both the sides, we will get the value as nothing but x minus 3 by 5 whole square would be like of the form square root of 19 by 25. Square root of 19 by 25. So if we are taking the square root, then definitely a sign of plus minus would come with it. So definitely a sign of plus minus would be there, or we can say that we have taken square towards the other side. So if we'll take square towards the other side, so it would be of the form of square root, and it will have two signs, that is positive as well as negative. So it means that if we are taking the square root on both the sides, then we will have x minus 3 by 5 of this equation. Let us suppose I am calling it as 3. which is equal to plus minus square root 19 by 25. Furthermore, we can write this equation as square root of 19 by 5 because square root of 25 is obviously 5. Now again we can write it as x minus 3 by 5, which is nothing but is equal to plus minus square root 19 by 5, and furthermore we can write it as x is equal to 3 by 5 because negative over here, if we'll take it toward the other side, so this would be plus minus square root 19 by 5. Now from this particular value, we can say that x has two values depending upon the sign, and what are those? X can be 3, let us suppose if I am taking the LCM, x can be 3 plus root 19 by 5, this is the very first root, and x can be 3 minus root 19 by 5. Depending upon the sign of root 19, we have these two as nothing but the roots of the given quadratic equation. So this is nothing but the whole algorithm or the whole procedure which is actually used for completing the square of a quadratic equation. I hope all the steps related to this is nothing but all clear to you.